In this week's episode, I'm joined by Outlaw Number 38, Mike Curtis-Rouse. Mike is an orbital architect and a pioneer in the UK space sector. We discuss his early life as a creative and inquisitive child, always taught to ask why, and look at how this mindset helped him evolve to become the innovator he is today. This is a great episode for any young budding innovators, scientists, engineers, people interested in space, to understand the journey it takes to get there and to understand what is going on and going to happen in the future. So without further ado, I hope you enjoy this episode. Perfect. Okay. Mike, we'll start. You are Outlaw Number 33.
Fabulous.
Thank you very much for coming on the Valley of Outlaws podcast.
Absolute pleasure.
An episode I'm actually very interested to see the direction we go in. I think there's a lot of interesting topics we can talk about, but always in the podcast I ask the same question to allow you to have your own version or way of telling and introducing yourself to the audience. So in your own words, who are you, what do you do, and why do you do what you do?
Great question. I mean, it isn't always a great question. So I'm Mike Curtis-Rouse. I suppose I define myself as an orbital architect. I'm building fundamentally trying to build the frontier of space. And we always talk about the frontier of space, and you can never really achieve a frontier. It's always a bit further away. But that's the fabulous thing about something exciting. So what am I? I'm an orbital architect. I'm an engineer. I'm a material scientist. I'm an entrepreneur. I'm a disruptor. I own and I'm building, or maybe own is too grandiose a term. I have a team and I work with a huge ecosystem of engineers and scientists and strategy folks and things like that, entrepreneurs, etc. And we're basically trying to build the capabilities that are going to allow humanity, society, industry, civilization to basically get into space and then do exciting things in space. And you might say, aren't we doing exciting things in space already? And yeah, sure we are. But to do the really exciting stuff, to go beyond, that real sense of going beyond the final frontier, we need the equivalent of kind of like the M25. We need a highway to basically run our cars on, is that our spacecraft. We need to basically have fueling depots where we can charge or refuel our spacecraft. We need to have effectively warehouses where we collect and store material. We need to have shops and factories where we build things. And we need everything else which goes with that: navigation, communication, maybe, where do you get your fast food in space? Right down to, fundamentally the basics. Yeah. So we're building that architecture, and that's a combination of robotics and structures and systems, right down to kind of the more mediocre things, which are as important. How do you do plumbing in space? How do you ensure that your shower works, that you can basically have a hot meal at the end of the day, that your loo works, etc. Fundamentally human basics, but make the real difference between doing something in a way which is hard and difficult, and you probably never want to go back, to doing something which makes you feel, wow, I've done that and I can now go to the next stage.
Interesting. I've got loads of images running through my mind and things which Elon Musk has said, and the ideas of leaving the Earth. Is that a long-term goal in terms of this kind of thing? You can try and make space more appealing than Earth?
I mean, fundamentally, if humanity really wants to survive, humanity has to get off the Earth. I mean, if you really want to look at the basics of it, in tens of millions of years, the sun will go cold. I mean, okay, if we get that far, we're doing really well. At that point, cats have probably evolved to have basically opposable thumbs, and we're all in trouble. But the reality is that if we want to ensure our species survive and we don't get basically hit by a near-miss meteor heading towards the Earth, or an AI deciding to take over the planet or something like that, then we need to get off this world. But we also need to get off this world if we want to basically protect the Earth. If we want to get to the point where we can turn the Earth into a utopia, where we're not constantly strip mining effectively the soil for minerals, we're not polluting the atmosphere, we're not cutting all our trees down, the best place to find material is not on Earth. And that, there's such a huge abundance of material elsewhere in our solar system, in our galaxy. I mean, I won't even talk about universes because that's going a stage too far. But realistically, if you want to do something fabulous, if you want to basically protect your planet, the best thing you can do is don't do anything to your planet and go and get stuff from somewhere else. So, in a nutshell, absolutely will. We need to get off the Earth to go and do other things. But I mean, equally, why wouldn't you want to?
Well, that's a good point. The exploration is always the most interesting part, isn't it?
Yeah, absolutely. I mean, whether if you're a cub or a scout when you're younger, basically, and you want to go backpacking into the woods or do the Duke of Edinburgh Trail or something like that, basically, that's all fabulous. Space is just the same. it's a bit less inaccessible. But I mean, is it really? I mean, fundamentally, when we define space, space is closer to us than we are to Glasgow right now. So the reality is space isn't that far. Now, yes, is it hard getting there? Yeah, absolutely. Is it dangerous? Sort of. No one's died recently. People do die. They will continue to die. But, at the same time, people die crossing the channel. So, that's not so crazy. So the reality is space isn't that far away. If you can get there and you can get more and more people there and you can get more and more architecture there and more infrastructure, it becomes easier and easier. And, as Carl Sagan said, basically, once you're in orbit, you're halfway to anywhere, and you are basically halfway to anywhere. I mean, probably once you pass your driving license, you're pretty much 90% of the way to anywhere as well, sort of thing. I mean, you have to have a car after that and all of that, but fundamentally, if you can get those basics, if you can get into space, if you can get into orbit, okay, it is harder to get away from the planet, but that's basically just the rocket equation. That's just basically more fuel, etc. Go faster. Assume you can do all of that. I mean, the big problem is where next?
Good point. Okay, before we go, I really want to go into the subject a lot more, but I want to also start with your journey to this point of getting into space, because I always think it's super interesting understanding what you saw for yourself when you were younger and what you're doing now. Is that actually very similar? So like the vision you had when you were at school or whatever, were you always going to be involved in the space industry? Was that always a big thing or interest for you?
It's funny, I was looking at my kind of personal statement when I was back at 14 or 15. And I spent, to be fair, a large proportion of my childhood basically both loving science and technology and at the same time trying to make every variant of explosive I could, much to the unhappiness of my parents and the local law enforcement. Not in an unpleasant way, just mostly like blowing things up because it was fun. But I was reading my personal statement back when I was 15, and it said basically, when I'm an adult, which at that point seemed a long way in the future, I want to basically work in nuclear fusion. I want to work at the Cullum Energy Centre on the Joint Energy Torus experiment. Okay, that didn't pan out. I mean, I did a little bit of nuclear physics. I did some work at CERN, etc., and things like that. But I ended up then basically spending the majority of my career today at Harwell, which is the opposite campus of Cullum. So actually, in reality, pretty close, really.
Yeah,
so
definitely
not doing space per se, but I mean, in reality, fusion is pretty much trying to create miniature stars.
Yes.
And while I don't create miniature stars, or at least intentionally, the reality is I work with a lot of folks who are doing nuclear for space in terms of people like Rolls-Royce who are trying to build reactors to go to the moon, or modular reactors to use in space, or nuclear thermal propulsion systems. British Interplanetary Society is desperate to build a giant UK spacecraft which will go to the outer planets. Probably will never happen, but it's great to have ambitions. So I guess in a way, I didn't quite align with my ambition as a child, as a young adult, but I certainly got pretty close.
And what were your passions when you were younger as well? Apart from blowing things up.
Well, apart from blowing things up, I weirdly had a passion for archaeology. I loved the concept of archaeology. I loved the ability to dig up the past, but I was also interested in future archaeology, of looking to the future and wondering what they would make of our society now, basically. So kind of archaeology in reverse. At that time, reconstructive archaeology didn't really exist. Had it existed, I probably would have crafted a career in terms of trying to work out how they built the pyramids, or building water wheels, or building muskets and things like that. That's a really exciting way of kind of understanding what we did in the past, and equally fundamentally, how does that influence the future? So big passions around archaeology, big passions around chemistry, hence links to explosives and things. I was an early, I suppose, adopter of robotics. I spent a lot of time building robots to do a variety of things: wheeled robots, legged robots, very crude ones. All based around the premise of, at that point, trying to fight fires. I don't know why I was obsessed with building robots to fight fires. And I remember one of my early ones in my lower six, I built. I mean, it was designed to fight fires, and on the demo day when we were all showing off our projects, I mean, yes, arguably it did fight a fire, but it was also the cause of the fire at the same time, and it roamed around the classroom, basically shrieking various robotic screams of pain, evidently, while basically trying to extinguish itself and burning at the same time. I mean, I got an A, so I mean, clearly somebody liked it, but that probably wasn't quite the direction I wanted to go in.
Did you find kind of the schooling, like education, was something which was limiting or enabled you to push yourself further, or did you do most of your own kind of exploration and kind of like growth outside of the education system in your own time?
So I was, I was fortunate to have parents who basically very much believed in curiosity. I had grandparents who were mining engineers, so that kind of helped. Particularly growing up in Cornwall, where part of my other hobby was climbing down every mine shaft I could find. Again, much to the unhappiness of my parents and those landowners, etc. But I was always encouraged to basically ask why, look up. If I took something apart, as long as it wasn't something critical to the house or the car, etc., or so on, then I was generally encouraged to learn more. So in a way, my ecosystem within sort of academia, within school, was certainly there as a good framework to basically provide the kind of conventional de rigueur. But at the same time, I had that kind of environment of friends, family, grandparents, etc., who were really keen on understanding, why does the world do these things? How do we build things? Why did the Romans build straight roads as opposed to roads with roundabouts, for example, etc., and so on? So having that kind of ecosystem growing, basically, I mean, I don't think if anyone grows up in an ecosystem like that, it's very hard not to basically grow and ask questions of both yourself and the wider world.
Mm-hmm. And what do your parents kind of do? Were they in a similar kind of space, like similar kind of areas? You like technology, science? That kind of
No, my father is a head teacher. In secondary education, and my mother was a primary school teacher. Basically, so both with backgrounds. My father studied classics at university, and my mother studied English literature or something like that. My mother was born in South Africa. My father was English. So I spent quite a lot of time in South Africa. Grandparents, mining engineers, kind of all ties together. But they were both fascinated by a combination of archaeology. My father was probably an engineer who never quite found his calling, etc. So, in my sort of, I guess, when I was 10 or 15, we were actively building things like trebuchets and things like that, quarter scale ones, to fire sort of melons 100 meters, etc. and so on.
That's amazing.
And there was always that kind of encouragement of, go and explore, etc. I mean, going and explore didn't always involve, or probably from his perspective, didn't involve trying to make gunpowder with the ingredients in the garage, etc. But at the same time, I was never told, don't do that. I was told, don't fire cannonballs at the cat, sort of thing. That's bad. But the sort of discovery of, if you mix X with Y and then you crush it together to incorporate it, etc. Let's not do a one-on-one of making explosives. We'll both get into trouble if we do that. But you do X, Y, and Z, and you incorporate it, etc. Then you can basically produce the equivalent of a high efficiency gunpowder, which then means if you cram that into basically a metal tube, you can fire ball bearings across the room, etc. and so on. So it was very much one of those environments which, despite having parents whose background were more the humanities, they were both interested in technology, they were interested in engineering, they were interested in the basic principles which underpin our civilization.
Do you think that the era you grew up in as well allowed you to explore these ways in a much more hands-on and better way? If you were a young child now, do you think you would be limited or more?
I'd probably be arrested, I suspect. I mean, I think that's a really interesting question, Will. Is that kind of like that major difference now between, is our society more forgiving and more open to learning, or is it more restrictive? I think I grew up in the 80s and early 90s. I think then there was a bigger question of, or less of a question of what can you do. It was more a question of, could you do it, basically. So there was more freedom. And I think the world hasn't fundamentally changed that much in terms of what you can and can't do. But I think it has changed in terms of the barriers and the limitations it places. And our society has become more controlled. It's become more monitored. It's become more tracked. And it's become more concerned what individuals do. On one hand, you've got probably more freedom than you ever have had before. At the same time, I wouldn't suggest we live in a police state, but we do live in a state where everything you do can be tracked and monitored. Keeping a journal or a diary in the 1980s meant basically using something made of basically graphite and scribbling in a notepad. Even with early computers, there was still no real sense of the internet. Today, most people who probably keep a journal or a diary is probably electronic of some level, which means fundamentally law enforcement with the right level of access and brute force can read anything you do ever. You can track you at all times. They know where you are, what you're doing, what you're eating, everything in minuta. That didn't exist 30 years ago, and it gave you a different sort of freedom. But at the same time, today you have, people sometimes say, "I don't know what to do." There's just, I don't think there's enough opportunity. Everything's been done, and it's really interesting because I say to people now is, you've kind of got like three major benefits humanity has never had before, and that's almost global. is you've got unlimited access to data. The internet can basically, you've got unlimited, within reason, access to power. You can charge your phones, etc., wherever you like. And as a consequence of that, combined with communication, you have unlimited access to innovation and knowledge, which means you can teach yourself anything within reason. AIs, whether you call them AIs or not, are incredibly powerful tools for learning more, helping you as a kind of an imaginary friend along the way. Don't listen too much, but listen enough, etc. With all of that, in a way, I mean, I think that the harsh reality of life is there wasn't enough time.
Yeah, okay.
We only get as humans about 100 years. Let's assume we're not going to digitally upload ourselves, etc.
Yeah.
There's so much to do and there's so little time.
Yeah.
That's what worries me more than anything.
Yeah. I think you raised an interesting point about young people saying it's much harder. There's an element of thinking that my generation and younger generations just don't have the skill set which maybe your generation had to be able to think on their feet and think freely, because they're so stuck looking at screens, and technology is as advanced as it's been, has also been limiting for them to actually push their mind further.
Yeah, it's a really good point. I mean, in a way, my generation, we grew up with early computers, etc. I remember programming my first early Intel chip, which was an 8086, which is ridiculously small, but still 100 times more powerful than the computer which took Apollo to the moon. So, still massive gaps in terms of capability, but programming that in machine code, so then I could basically apply assembly on the top of it, and then eventually work out to the high level languages. Today, if you look at Windows, you don't see everything which really sits below it, unless you're a programmer at a certain level, but even then you have to go really deep. But at the same time, I think there is that ability to become more connected. So, the idea of being able to look at a highway, the pictorial representation of a highway in southern Chile, and basically see that there is a restaurant down the road and a hotel, and there's a small golf course, and there's a couple of llamas eating by the side of the road. You could never do that basically in a conventional two-dimensional map. So the world has become so much bigger. At the same time, I think, to take your point, it also feels smaller, it feels tighter, it feels more constrained. But I think the key part to it is imagination. Yeah. And part of it is being prepared to put down, basically, whatever is the electronic device that you perceive as connecting you, and recognize that while it is a connection, it's also a leash. Yes. Basically, it tethers you in location. So, periodically be prepared to put all your electronics devices down and walk outside and stare at the moon or something, basically, or watch the sunrise. That creates that separation, which basically I think is the same thing which is prevalent in my generation, in your generation, is the ability to connect with the world physically without needing to use electronic media to do so.
It reminds me, actually, I had Dr. Mark Bloomfield on a couple of series ago, but he talked about, as adults, the one thing we forget to do is play. As children, we play, we fail, we play, we fail, we keep doing till we learn. And we take life more seriously as we grow up, and we think we have less room to play and explore and actually be present with ourselves and go out and just try different things. And there's an element of what you're saying there. We're so restricted by technology and phones, for example, in a way where we're worried about our image. We don't have the time or the mindset to go out and try things and willing to fail and actually go and explore. And that's also probably what's limiting people's confidence and abilities to go and push themselves further and connect, as he said, to more of the natural world and things around us in a better way.
Yeah, absolutely. I mean, playing is, I suppose, something we take for granted. But to play, you have to have certain freedoms. And if you don't have those freedoms, it's very difficult. But I mean, I think, most children will find the opportunity to play however horrific the circumstances they find themselves in. So whether, it's in the rubble of Gaza, or, it's following the outcome of a major pandemic, etc., children have a natural ability to find somewhere to play. And that's, in the same way we dream, it's probably that ability, that sense of escapism, which allows the brain to relax, the body to basically adjust and attune itself to the environment and to continue to thrive and grow. If you took away the human ability to play, along with the human ability to laugh, even in the most dire circumstances, we probably would kill off the ability of humanity to grow at all. And that's probably one of the major things which separates us from almost any other species, is that ability to play. I mean, we see cats and dogs playing, but they are predominantly predatory reinforcement actions which come from the legacy of being larger cats and wolves and things like that. Humanity plays for no reason other than to play. And I think if one thing that you could pass on to your children, your peers, your descendants, etc., would be, as you said, is never give up that ability to play, because the moment you do that is you're giving up your imagination.
Yeah, completely. I want to go on to kind of your further education and after. So you went obviously to Manchester and studied science and technology, and then you went and joined the army and went to Sandhurst.
Kind of.
Kind of? Explain it. Tell me, what have I got wrong there? Tell me.
So I went to what was then known as UMIST, so University of Manchester Institute of Science and Technology, read mechatronics there. That university merged with the University of Manchester. At the time, it was kind of the equivalent of the northern version of Imperial College, just probably with more girls and alcohol. And that merged with the University of Manchester in about 2010. Whilst at university, I joined the Officers Training Corps, the OTC.
Yes.
Actually, I mean, to just wind that back slightly, I spent a year before that very happily running around the woods doing live action role play dressed as a dark elf. But my father told me that this was not an acceptable way to build a career in any capacity, and I couldn't. I wasn't allowed to run around the woods being a dark elf fighting imaginary dragons because that just wasn't going to help my career.
Yeah.
So he spoke to a couple of friends, and they suggested that I join the Officers Training Corps.
Okay.
Initially, I was sponsored by the Royal Corps Signals as a regular Army officer, but after going on a series of familiarisation visits, I realised really rapidly as an engineer, I like getting my hands dirty. And at that point within the British Army, the idea that an officer would remotely basically get their hands dirty rather than basically not necessarily sitting in a Chesterfield and drinking fine wines and eating cheese and point, you move that over there. Not quite that, but that really didn't appeal. Yeah. So I pivoted to what was then the Territorial Army, and pursued basically a kind of dual career. So post-university, I achieved my commission as a Territorial Army officer at Sandhurst, so in a compressed military commission. So that's 3 weeks, but with 2 years of basically prior training. So it still equates to sort of 44 weeks of a regular Army officer. Yeah. And I pursued a Reserve Army officer career at the same time as pursuing a career as an engineer and as an innovator and as an entrepreneur. So it's given me an element of duality at the same time.
So what was the kind of the goal with having that? Was there a benefit for you in terms of actually having that freedom and that exploration and fun and physicality in the army, and then having the kind of science? And
I mean, arguably, I did tell my father it was because it gave me direct access to explosives, which he wasn't particularly thrilled by. But no, you're right. It was being an engineer gave me access to the ability to apply technical ingenuity to solving problems. With the army, it is about problems. It's always about problems, but the problems are more people related. And how do you bring people together? How do you capture the innate essence of leadership? How do you use that to ultimately persuade people to do things that they wouldn't otherwise do? Hopefully in a way that they're going to enjoy it, not always. And that duality gave me the ability to see leadership in action in a very different way than in the engineering world. I mean, you could argue there's a very little difference between leadership. For me, leadership is ultimately fundamentally about having the accountability to own the outcome, regardless of whether that outcome is good or bad. But at the same time, being able to take people with you in the most challenging of circumstances. Yes. And you can encounter that in technology, and you can encounter that in conflict. Arguably, there's little difference.
And I mean, do you think that actually doing something like that is a recommended step in young men's education, or young women's as well, education, of just having that duality as well, kind of learning? And also, I did CCF at school for a little bit, and as much as I say, I really didn't love it, but I did respect the kind of practice of it, and actually the authority and the kind of ranking of people, and knowing your place, and learning and making your way up through that, working as a team, as you said, following the leadership of certain people, and actually being given opportunities to actually lead in certain aspects. But do you think that's a thing which maybe we should be incorporated into education a bit more, where we look at London now, we've got so many kids on the streets and in gangs and stuff like that. And a very easy thing to say is, we're going to put them in the army and then they'll straighten up and do that. Is there an element of bringing that into education a bit more, which will actually help younger generations?
Yeah, no, I think you're right. A military ethos doesn't have to be military, but a kind of volunteer ethos, etc., gives a sense of hierarchy. It gives a sense of direction. It gives a sense of self-discipline and commitment and responsibility and ownership. And I think that's something society is missing. Would I suggest reintroducing a national conscription? Probably not, but military service, but met with the option to do military service or to do service within one of the emergency services or within the social community or forestry or Coast Guard, etc., I would think would go a very long way. I think a lot of, and it's easy to speak about younger people without being them, but I think there was a perception that they generally feel a bit lost. The world is a complex, fast-moving environment, and you have to. I mean, periodically, I feel somewhat overwhelmed by the amount of technological development. And generally, I put myself in a bracket. If I find that overwhelming, if you're from a non-technical background and you haven't grown up with a similar based infrastructure and without effectively the discipline to work out how to focus, etc., then it must be absolutely terrifying.
Yeah.
So I think in a way, many people would be very reluctant to do any form of sort of military service, but I actually think they would fundamentally embrace it at the same time. And I think the CCF, and CCFs are sadly basically waning across schools, but I think they are extremely good frameworks, basically. One of my last military posts was commanding the senior division of Oxford University Officers Training Corps.
Okay.
And I had numerous students from Oxford University, Oxford Brookes, and Reading University and other similar aligned universities. And it was really interesting to see the motivations of why students would join the OTC. And some of them were joining because simply they were going to regular Sandhurst and they were going to take a full career in the British Army. Others were doing it because they wanted discipline, they wanted commitment. Some were doing it because they simply said, it will be the only chance in my life I get to do something like this. And I want to be able to do this and say that I did it, even though that when I leave the OTC in 3 or 4 years, I'll never do anything like it again. But I suspect every single one of those individuals, all of those officer cadets who went through that training cycle, they all left with something which made them realize that they could do something which was greater than themselves alone. And I think that's one of the really key aspects of recognizing as a citizen, as a member of society, you should never be doing it just for yourself alone. You should be doing it for the greater good. And the moment you realize that, suddenly I think it puts things into really, really clear perspective. Why would you be rude to someone on the street you never met before? Why would you litter? Why would you commit to act of violence to someone, to an object or a person that you've never encountered before? It suddenly makes you realize that you were responsible for your actions, and your actions in turn can influence both for good and for bad others.
No, I think that's a very fair point. Very fair point. Can we go on to kind of early stuff as well, like CERN and STFC? Like, firstly, CERN is the Hadron Collider. I forgot is.
Yeah, CERN's a big donut which accelerates particles in a very excited way, round and round to the speed of light.
So, what did you do there? How did you get into that? Was that a logical step?
So my first job out of university actually was I joined a database company because they were offering me a lot of money and it sounded very exciting. And then I realized it was the worst possible thing in the world. Money doesn't make the world go round. I mean, it does, but it's not very exciting. Just frankly building relational databases. So I bailed out of that very early, and I'll never want to ever go back to that again. So I then joined what was then known as Rutherford Appleton Laboratory, and still is to an extent, which is part of a wider government organization as what we call a system engineer. And that's basically bringing a variety of different technologies, electrical, mechanical, material, mechanical, and so on, together to build greater systems. And you could ultimately have a system engineer building spacecraft, you could have one building cars, you could have one building toasters if you want to. But I was working on a project known as Atlas, which is one of the big detectors at CERN. Atlas was the detector which eventually discovered the Higgs boson. So along with 4,500 other scientists and engineers, I get my name on that paper. It'd be great if it was just my name, but sadly it isn't. Still, I'm willing to take it. So Atlas is a giant detector. It's about the size of St. Paul's Cathedral, built 100 meters underground. It's one of the most complex machines ever built on Earth. It's probably been superseded by numerous other detectors now, but still a very complex machine designed to detect the tiniest interactions of particles being accelerated to the speed of light, and then basically, in theory, during that collision, being able to look into that collision and determine, based on energies and subatomic particles, etc., whether this magical particle, this magical phenomenon known as the Higgs boson, existed or didn't. I mean, it's a slight irony about particle accelerators. You have to build accelerators and particle detectors which are city-sized in order to detect the tiniest things.
How oblivious the general public is to the advancement in kind of the technology in that kind of space?
I think completely oblivious, actually, and I think that's probably a good thing, because if you realised how much money we spent and how long, I mean, CERN was the Atlas experiment was being designed and built before I was born. I was one of the last engineering teams to put kind of the final pieces together. The data will still be continued to be analysed for another 30 years.
Wow.
So these are basically, these are century-spanning experiments. And they're already now talking about building a larger Hadron Collider, because this one's the diameter and the circumference is too small to detect the new particles they want to detect. So now we want to build something which is an order of magnitude bigger, which will cost a ridiculous amount of money. But it's actually the fallout of it, of the things that you get that you don't realize. So better ways of storing data in terms of extremely high density memory, new ways of treating cancer, new materials which allow us to build lighter and more fuel efficient aircraft. All of those come out of technologies like this. But you can't say that you started off wanting to detect a particle. I don't know any physicist at any university which would say, we're going to detect this, but by the way, we're going to come up with a better way of making your trainers waterproof. That doesn't happen, basically. Yeah. But somewhere along the line, some agencies, some government, etc., will go, well, you have to do better than that, guys. You're going to have to tell us, what are we going to get from it? We're going to get really stretchy cling film, which doesn't tear. Brilliant. Okay, there's 100 billion for you.
And STFC, is that?
STFC is the parent organisation of Rutherford Appleton Laboratory, also owns the Daresbury Laboratory in Warrington in the northwest, also owns the Astronomy Technology Centre at the Royal Observatory in Edinburgh. Okay. It's a parent organisation, a government organisation, which basically runs large scientific facilities. So in the US, for example, there's lots of big government labs, and they're all run broadly independently or under the Department of Energy or Department of Defence. In the UK, we have research councils. Research councils own either projects and grants and funding mechanisms, or they own facilities. So, for example, the NERC, the Natural Environment Research Council, owns British Antarctic Survey and also owns the British Geological Research capability as well. So these are kind of government organisations which own things. They can make it sound very boring and very dull. They actually, in some cases, own some fabulous capabilities. So STFC, not only do they own some very large particle accelerators at Harwell, which is where one of my organisations is based, they also own one of the largest and most powerful lasers in the world. Okay. When I say most powerful, the output of the beam is the equivalent of all the sunlight simultaneously falling on the Earth at any one point. Wow. Caveat, it's only for a split second, a picosecond, sort of 10 to the 12, 10 to the minus 15. Ridiculous amount of time. So to put that into comparison, it would take you about 7 years to boil an egg. But at the same time, it is equivalent. Basically, it's a very, very, very tiny little Death Star firing. So it's the same energy that you find inside a star. And with that, you can do all sorts of amazing interactions of understanding how stars function, or understanding how you build nuclear fusion reactors, or understanding how materials operate under really extreme conditions. But it's just for a really split second.
Interesting.
So exciting, but very short.
Yeah, interesting. The whole innovations part of being in this space as well is fascinating, because you've given a few examples, things going on all the time in different directions, all for the advancement of our knowledge. But in terms of also like what you're doing, obviously, in getting into the space side of it, I know that you're involved in the robotics and the 3D printing. Like, how much of those technologies like have allowed us to advance as well in our scientific research and our ability to create and deliver new technologies?
So robotics, let's separate those slightly. So robotics is going through its own revolution right now. We've gone for quite a long time where basically software from a robotics perspective has actually been pretty advanced. Advancements in self-driving cars, aircraft broadly take off and land themselves, ships navigate themselves, etc. So there's been a huge amount of technology progression there. The caveat, though, is the hardware hasn't really caught up with it. But suddenly we're now seeing this mass advance in terms of humanoid robots, quadruped-based robots, better grippers, better end effectors, etc., and so on. So suddenly we're seeing this convergence now of the technology, the control systems, etc., meeting the hardware. So realistically, we're going to see in the next 5 or 10 years, we're going to start seeing robots of all shapes and sizes basically physically manifesting on our streets, in our hospitals, and our factories. Wow. So it's going to be, it's going to be a mass transition, not quite perhaps kind of like iRobot territory, but maybe not far off either at the same time. Robotics is, the key thing about robotics in a way, though, is it's not the humanoid robots you see, it's the robotics driving the manufacturers of cars, planes, ships, etc. And in terms of science and innovation, it's exactly the same, except what we call robots don't really look like robots. They're the automated systems which allow us to faster pharmaceutical research, allow us to do new alloy discovery and things like that, handling complex and very hot materials in furnaces, etc. So that's been a major driver. The flip side to that, then, of course, is advanced manufacturing. So 3D printing, what we also colloquially call additive manufacturing, or also net shape manufacturing. Net shape manufacturing basically changes how humanity has made things the last 50,000 years. So pretty much prior to this century, everything we ever made from a manufacturing perspective was basically, it was wrought, it was cast, it was poured, it was cut, it was diced, it was assembled. And that's what we call subtractive manufacturing. You start with something, so you want to make a mug. Basically, you take a block of clay, you make it into a rough, basically, ball. You scoop out the middle, you fire it, and there you have a mug, basically.
Yeah.
Additive starts on the premise that you start with basically exactly the amount of material you want to build your part with.
Okay.
And then you basically glue it together. And when I say glue, I mean you can glue it together, and some additive manufacturing 3D printers do glue things together. If you look at, most children now will have had access to some form of 3D printer in their education, and broadly those work like a glorified glue gun. Basically, you're melting plastic. Everyone generally has used a soldering iron at some point to turn solder into lots of blobs of more solder. Very infuriating if you want to do electronics. You discover all your solders now in this big blob. But in the same way, using a glue gun in the same way, that's how kind of the basic 3D printers that most people see.
Yeah.
But the more complex ones, the ones, for example, my team operate, which use very high-powered lasers, not the sort of Death Star-style lasers, but still pretty high-powered lasers which melt metal. We take metallic powder, aluminium powder, for example, and then we melt it in layer after layer, and we basically use that to build structures together. And you can build all sorts of amazing constructs. So one of the biggest utilizations of additive manufacturing, for example, is in the medical industry.
Okay.
Almost all medical implants are basically 3D printed. So whether you have a knee replacement or a hip replacement, or you have a stent to spread open a vein, etc., all of those basically are manufactured using 3D printing. But at the same time, the gas turbine industry for aircraft and power generation uses additive manufacturing to build turbines, and the rocket industry, almost every single rocket engine to date, is manufactured using one flavor or another of a 3D printer. So that's rapidly changed how we build things. And the more interesting aspect to that is, and it's a little bit about technology, if you wanted to make something really complex 20 years ago, you would need to go and find a precision engineering workshop. Today, you can basically do a design at home on a relatively standard computer. You can send it to a prototyping lab facility online. It's somewhere in the world, and 3 or 4 days later, that part will turn up. Or for a small investment of £10,000 to £20,000, you can build yourself a workshop which allows you to build incredibly complex objects that 20 years ago you would have been unable to buy that capability. You could have spent £100 million and not be able to build that capability. So very rapidly, we're seeing this growth and this surge of effectively kind of almost like domestic workshops and fabrication plants just popping up in the neighborhood. I mean, random fact, we have lots of space companies on the campus where I work. However, 5 or 6 of the biggest new space companies are based in London. They're building satellites, They're building robots, they're building new types of products to go into space, they're building satellites. Why? Because you suddenly don't need a giant factory to do these things. So I'm fairly certain there's a company about 2.5 miles from here, basically, who are building robotic arms to assemble things on the moon. And they're doing that in a warehouse, a small warehouse, basically a couple of miles from here. You would never have imagined that.
Yeah.
You assume that factories and things like that basically are in big, complex science parks, industrial parks, in the sort of like the dark corners of the UK, not in the middle of the bright capital.
Well, it kind of leads on to my next question, which was all about this kind of advancement in technology and with manufacturing. It almost brings us back to a point where we can be self-reliant on ourselves rather than having to go to China, Asia, to rely on them to make what we want. And I think that's a huge benefit as well, because as you said, it cuts down the speed of time it takes for you to actually test, experiment, and see how things work. I think that's a really important point. It's interesting. I've got a friend who's an architect in Portugal who's specialising in 3D printing houses at the moment. And half his research is testing different materials and how they can 3D print them and how they weather, how long the house lasts, how long is it going to take to build, the impacts. And I think that ability to just manufacture on the go almost in your own space is going to be a game changer for innovation, especially for a country like the UK where we're almost becoming very much a quaternary sector now in terms of manufacturing. We already are a quaternary sector, really. It's going to give us much more independence, isn't it?
Yeah, massively. That kind of ability to be self-reliant, but also have the equivalent of kind of like micro factories, basically, where you suddenly don't need a giant facility. You can manufacture to suit your own needs at your own time with your own skills. You can adapt and overcome. You have huge amounts of agility. That's hugely attractive. And I think that will fundamentally change things in terms of how we're building and where we're building. And that kind of lends itself to what the term reshoring, kind of the opposite of offshoring. If the UK wants to bring its manufacturing capability back, at least at the high end, I mean, we probably don't want to manufacture phones and things like that.
Yeah.
It doesn't really make any sense. The reality is nations like China, Malaysia, Singapore do that far better, far faster. And they have ecosystems which are designed to do that. But if we want to do the kind of high value manufacturing in the UK, then the growth of small micro factories, micro fabrication capabilities, etc., I think is not just appealing; it's essential.
Yeah, no, agree. Can we talk about Satellite Applications Catapult?
Sure.
Explain what it is, what you're doing, and kind of the mission with the whole thing.
Sure. So the UK has 9 catapults. Sadly, the catapults don't catapult things into space as much as we might like them to do so. There was a company called Spin Launch who was trying to do exactly that, but we kept trying to stay away from them.
Yeah.
So catapults are basically technology innovators and bridge builders. So 9 catapults in the UK, they all focus on core strengths, high value manufacturing, semiconductors, offshore energy, digital, transportation, etc. Unsurprisingly, we focus on space. Satellite applications is a bit of a legacy from our past when we used to do a lot of work in terms of taking data from spacecraft and commoditizing that and turning that into products. But what we really do is we bridge what we call the Valley of Death. So there's this concept known as technology readiness levels. They go from, weirdly, 0 to 9, a NASA-derived standard in the 1960s. 0 is a concept of if I could put a horn on a horse, I could call it a unicorn. And 9 is basically I have a space-grade ready unicorn that I can deploy into space at a moment's notice. In the middle, there's what we call the Valley of Death, TRL 4 to 6. And that's kind of where I have a horse with a unicorn on its head, but it's not a unicorn. And 6, whereas I have a horse which has a horn glued to its head and it is a unicorn sort of thing. How do I get from one to the other, basically? And most companies, many universities will fail at that a level, simply often because it's down to resource, or it's down to technical knowledge, or it's down to the ability to commercialize, etc. Catapults are designed to bridge that gap. So we bridge the gap and part of our role is to basically grow the UK space sector, grow GDP, increase the number of jobs, but fundamentally help organizations bridge that gap. And we do that through a concept known as missions. We have 3 missions, and they all link to different parts of society and industry. One of them is focused on sustainability. So how do we ensure the Earth is sustainable? How do we ensure that we protect our natural infrastructure, our natural environments? How do we build things in such ways that we don't damage the world, damage society, etc., and so on? So that can be linked to forest fires, that could be linked to flooding, that can be linked to building economically, etc., and so on. We have another mission which is linked to, which is called Connected Earth, which is linked to autonomy and connectivity. So how do we build better connectivity? How do we ensure that when you travel between 2 different cities, your phone signal on the train doesn't just simply disappear, as it often does? How do we utilize satellite communication, etc., to empower that? And then finally, the mission that I'm actively involved in and I lead, which is known as Beyond Earth, is focusing on the technology which is relevant to not being on Earth. So how do we build the infrastructure space? How do we build satellites which basically are more sustainable? Because right now, all satellites are basically time expired. You build a satellite, you launch a satellite, it either runs out of fuel and then it deorbits, or it doesn't deorbit if you're unlucky, or it becomes fundamentally completely useless. We're trying to get to the stage now where satellites can be serviced, where they can be refueled, they can be replaced on orbit, even possibly recycled. But then everything else which sits around that, basically, in terms of how do we build the infrastructure in space which allows us to make things in space which we can use in space? So is that a space-based solar power station? Is that a massive orbital data center? Is that a giant telescope? Is that a new particle accelerator around the moon? Could be many things. Also, how do we make things in space that we can use on Earth? So new types of semiconductor, new types of alloys, new types of drugs, using the microgravity environment to manufacture things we simply can't make on Earth. And then we bring those back on Earth to benefit society, to benefit industry, and ultimately grow our civilization.
Interesting. Do you think, I have always had the perception that satellites, once they're kind of decommissioned, they just orbit around. Am I wrong? There's a lot of wasteful dead bits.
You are both right and wrong.
Okay.
So depending on your orbit, spacecraft live in different orbits, and broadly there are 3 orbits, basically: low Earth orbit, LEO; medium Earth orbit, MEO; and geostationary orbit, GEO. LEO's actually not that far away, between 200 to 4,000 kilometers away from where we are right now. MEO is a bit more, 10,000 plus, and GEO is something like 36 to 40,000 kilometers. If you're in GEO and generally you run out of fuel, etc., and your spacecraft isn't moved into graveyard orbit, which is an orbit where we keep, unsurprisingly, dead satellites.
Yes.
Basically, you could be in that orbit for thousands of years.
Wow. Okay.
If you're misfiring on a propulsion system and that the spacecraft is getting progressively lower, it potentially will burn up eventually.
Yeah.
Conversely, if you're sitting in MEO or LEO, typically those spacecraft will deorbit, but that may still be hundreds of years, even thousands of years in some cases, depending on where they are.
Wow.
Most spacecraft increasingly have to have some form of propulsion on board of them to ensure that when they basically get to the end of their life, they can deorbit. So they basically direct their propulsion system to bring them closer to the Earth, and then the atmospheric drag brings them down and they burn up.
Okay.
So SpaceX at the moment are burning up something in the region of 10 to 15 tons of satellites, typically a week.
Really?
Ones which out of their constellation, basically, which are defunct or being replaced or have other issues.
Wow.
And that happens on a regular basis. So next time you look up and you see basically a shooting star, it's as likely that is a satellite burning up as it is actually a meteorite.
That's fascinating. Okay, because I've always had this impression of going out to space, you've got to avoid all these dead satellites.
It's getting pretty serious. I mean, right now SpaceX have something in the region of 7,000 to 8,000 spacecraft in orbit. Amazon are building their new constellation Kuiper, which they haven't got many. They've got, I think, 129 spacecraft. Another 37 went up yesterday or the day before. But they're going to be building that out to about 3,500. China's building 2 or 3 constellations of somewhere between 5,000 to 12,000 spacecraft each. The European Space Agency is going to launch something called IRIS², which is our equivalent of Starlink. So that's probably another 2,000 to 3,000 spacecraft. OneWeb have a couple more thousand spacecraft, etc. So, 10 or 15 years ago, we had about 4,000 or 5,000 spacecraft. By the end of this decade, we'll be peaking around about 100,000.
So who regulates the numbers for that?
No one really is the short answer. Notionally, there are a variety of organizations ranging from the UN to the International Telecommunications Union and a variety of other bodies who are responsible for licensing. Fundamentally, every nation is responsible for licensing the spacecraft which launches from that network, which is launched by a company which resides in that nation. So OneWeb, notionally, who are partially owned by Eutelsat, but have headquarters both in London and France, are regulated by both the UK and France, basically from a licensing perspective. US spacecraft are licensed by the Federal Aviation Authority, etc., and so on. But that also means that you find countries like Papua New Guinea have their own licensing as well. And a large challenge currently in the industry is how long does it take you to get a license? In the UK, with our fairly fledgling space agency and fairly fledgling licensing agency, the Civil Aviation Authority, it can take anywhere between 12 months to 2 years, which is a pretty long time.
Wow.
In Papua New Guinea, if you exchange the right amount of money, you can get a license in 6 to 8 hours. Which is more problematic because with spacecraft licensing also comes insurance, i.e. what happens when something goes wrong with your spacecraft and it hits someone else's. Yeah, okay.
Does there need to be, at one point, a space body which everything has to go through?
I mean, ideally, yes. I mean, in my head, that's the United Federation of Planets, but we're probably not there yet.
Okay.
But yes, fundamentally, we need something which takes accountability of everything in space, simply because space is one of those places where you can't say, oh, don't worry about me, I'm doing my own thing. Because chances are you're going to be affecting someone else at some point.
Yeah. It kind of makes me think a little bit about how Antarctica's split as well.
Yeah, that's a really good analogy, actually, in terms of and how Antarctica operates, etc., and how there's kind of the rule of Antarctica in terms of do no harm. But I think the other analogy is probably a sort of international maritime law, i.e. basically, a ship in need, the premise is everyone will assist you if you're in need.
Okay.
Basically, and in space we need something pretty similar.
Okay. In the UK, then, how advanced are we in our innovation in the space race? Like, are we well behind? Well, I would presume we're well behind China, America, India, most of the countries. How close are we to catching up or getting into some sort of race?
So it's always a race to an extent, but it's an economic race more than it is a military race, really. You're right. China and the US are definitive leaders. Russia, France, Germany, all making significant headway there. Mm-hmm. The UK is a major player in many respects. We used to build more small satellites than anyone. We don't anymore. Mm-hmm. And those small satellites were usually being built by Scottish companies. That's not the case. SpaceX alone is turning out 100 satellites a week. That's something we're not doing. We do build big satellites. Airbus and partners build very large satellites, and we still dominate a large part of the large satellite building part of the industry. We do a lot around space data, space situational awareness, understanding what's around you in space, etc. We do a lot of data processing. So in those areas, we're probably in the sort of top 5 nations in the world.
Okay.
In terms of launch, we're definitely not. There's numerous UK companies trying to build launch vehicles, and we have several spaceports, all which are trying to make themselves into bona fide spaceports. They're a long way, all of them, from being operational.
Okay.
So in that respect, not so good. Human spaceflight, we don't really do.
Yeah.
We've had a couple of astronauts, Helen Sharman, Tim Peake, etc. We've got 3 or 4 astronauts like Megan Christian and others currently who are training. But there's a lot. Having an astronaut and having a flight for them are 2 very different things. We don't have much participation in the International Space Station. We might have some participation in the next generation space stations being built by companies like Vast Space and Axiom and Voyager Space, etc. But that remains to be seen. So on one hand, we're definitely not in the top 10. On the other hand, we probably are in the top 10. It kind of breaks down in terms of what do we do and how do we do it. The UK always punches above its weight, but we sometimes punch in strange directions as well.
Okay, next, what does the next era of space look like for us as a country as well? Like what are what kind of position do you think we might go in, which might help us become more relevant or lead in certain areas? Because we've always been innovators as a nation. Is it too late for us to take a lead in something else, or is there stuff where we can still push into, which actually gives us kind of the frontier of it?
Yeah, I mean, the UK has lots of key strengths. Some of our major strengths are things like manufacturing, autonomous systems, robotics, etc. So in terms of the area where we term ISAM, so in orbit servicing, assembly and manufacturing, which I focus a lot with my team, the UK is in a good position to basically do some fairly transformational things. So in particular, we've touched on earlier, talking about basically spacecraft and sustainability and burning up. The UK has 2 companies, one called ClearSpace, which is partially UK, partially Swiss, partially in Luxembourg, and another company called Astroscale, US, Japanese, and UK. Both those companies are the leading companies who are targeting on in terms of removing debris from orbit. Okay. So the UK is very much trying to drive and lead in terms of how do we ensure that space is sustainable. Mm-hmm. We might end up doing that, frankly, through less technology and less spacecraft and more through standards. But the UK has always done standards well. So ensuring that basically there were standards that the world meets from an economic perspective and an operational perspective to ensure that space is at least kept as clean as it possibly can be. Mm-hmm. In other respects, certainly as I've said in terms of manufacturing and materials, the UK probably has more companies than anywhere else right now who are planning to make things in space, make in space and return to Earth. So there are companies like Spaceforge, so the Welsh space company most people have never heard of, but set up about 5 or 6 years ago by Josh Weston and Andrew Bacon, both relatively junior engineers. They've raised about 30 million now so far. And they're basically building a free-flying space factory, which makes very, very high quality, very high performance semiconductors, which then come back to Earth and will go into a variety of products. Yep. You've got other companies like BioOrbit, Katie King out of Cambridge. Her company are basically focusing on next generation anti-cancer treatments, etc. Wow. So we're suddenly seeing a growth of companies planning to make things into space to better society, to better our industry basis, etc. So that's certainly where the UK is going to be leading. What does space look like in the next 10 or 15 years? It's going to be hard to tell, partially because it's going to be dictated very much by, I suppose, the militarization of space. There is a new space race in terms of who can get to the moon, because the moon is kind of arguably the ultimate high ground from a defense perspective. There's a real race between China, Russia, but equally India in there as well. India's got big ambitions, wants to build its own space station, wants to have its own human-rated rockets, etc., wants to go to Mars. Does it get to see that through? Questionable, but its population is growing fast and it's got a pretty strong economic base, so entirely probable. I think what we'll see in the next 10 years is someone will try and land on the moon, successful or otherwise. Someone will probably try and get to Mars, probably unsuccessful, which probably means fatalities along the way, but some nation will try that. But we're going to see a massive surge in terms of commercialization capability. So your iPhone or your Android device in the next 5 years may well not be using the cellular network to communicate. It will just be simply talking to a satellite network. So wherever you are on Earth, the idea of having roaming charges will just disappear. So, direct impact for the average citizen will be no longer having to worry about roaming charges. Your phone just connects to the satellite network anywhere you're on Earth, and you basically get super high speed data connection, which changes all sorts of things from economics to financial transactions to how fast you can receive Netflix, etc. So that has direct impact.
Interesting.
More satellite data, greater awareness of what's happening on Earth. I mean, can you imagine Google Maps in real time? So basically, you go to the pub and you want to know if there's a parking spot there. You look up on Google Maps and you can see there's 5 bays empty. Great, you'll go to that pub, sort of thing.
Yeah.
So we're going to see a huge surge in the amount of data we get from space. So those are going to be the perceptive things. And then the more fringe things will be things like asteroid mining missions, looking at doing things we call in situ resource utilization. So the growth of the first lunar bases, etc., and so on. You know, everyone always says, is it going to be exciting? I would say it's always exciting. 10 years ago, it was exciting. And in 10 years' time, it still will be exciting. So that excitement doesn't go away. I think what increases is the amount of participation by more and more people in space, where in the past it's been tens, maybe hundreds doing things in space. In the next 10 to 15 years, we'll see this growth of new commercial space station companies and more, where we've got hundreds, if not thousands, of people doing things in space.
Interesting. It seems also, from a limited perspective, that it might also be revenue based in terms of what returns these companies make on these products, because a lot of these things are obviously to service us back on Earth. There's going to be financial returns there, and and that almost makes it all very still individual, because from everything you're saying, my mind says there needs to be some sort of governing body, which all we need to be a united front which goes out the space as one, as apart from anything else. That seems to me to be like the most logical thing. But I think with this whole thing of creating these products which come back, it's just going to incentivize companies to be a bit more selfish and completely profit based.
You're absolutely right. We're moving to commercial space. We're not moving to government space, and it's what we call mostly new space or next space. It's this transition from, unsurprisingly, what we call old space, where it was predominantly driven by governments, government agencies, and a few corporations, to a world where suddenly it's fundamentally commercially transactionable. And actually, I think that mirrors society, basically. The world is more driven basically by the decisions of companies like Google and Microsoft and Apple than they are basically influenced by the decisions of their local government or their national governments, etc. The corporations have infinitely more power. I think space is in some ways, though, somewhat democratizing. It's one of the few places that mostly, irrespective of races to get to the moon, etc., that most people agree that we need to have sustainability, we need to have cooperation, etc. So yes, while there is huge competition between the US and China, for example, I can actually see that Europe, for example, forging a far closer relationship with China and potentially with India, recognizing that the best way to do space is to do it together, not to do it independently. Yeah. So, while the world might feel a little bit bleak right now and more than a little bit combative, actually space is one of those places, in the same way kind of international maritime law applies, where we do get together and we do talk to each other. If the International Space Station, and it will deorbit in the next 5 years or 6 years, basically, if it had a major failure and the Chinese space station could assist, I think there would be no question that the Chinese space station would assist. Conversely, if the Chinese space station had a major issue and the International Space Station crew could assist, they would. Yeah. It wouldn't be a question of, it's China, it's America, it's Europe, etc. We don't talk to each other. Yeah. It would just be a question of, how do we help you?
Yeah.
And that kind of transcends, I think, in a way, and that gives me hope for the future, that transcends the ridiculous sense of combativeness we see regularly in terms of competitive activities on Earth, that actually space is one of those places we do it together.
Yeah, it's ironic, isn't it? It's funny. Final space question, then we'll go to personal stuff. How important is SpaceX and someone like Elon Musk for the space industry? Because from my perspective, as someone who has very little knowledge, SpaceX seems to have ignited some sort of spark and interest and almost the competition in it, because they've been so public what they're doing, and people are seeing such advancements with their rockets and the satellites and everything which Elon Musk has for his plans for Mars. It seems to have accelerated public opinion and public awareness of it.
He's a very polarizing figure in terms of what he does and what he says. And I think one of the key things to remember about SpaceX or Tesla, or indeed any of the other entities that Musk is involved in, is while he may be the figurehead, they are made up of hundreds, if not thousands, of engineers, basically, all who have their own ambitions and dreams. And those people are very much shaping the destiny of those organizations. What Musk has done, I suppose, in a way, is he's demonstrated that space can actually be commercially viable by building reusable launchers and proving that out. And it's not just so much about the cost, because SpaceX has reduced the cost of putting things into space. It's about cadence and reliability. in the past, I mean, if you still see with other nations, rockets frequently launch and then they explode. I can't remember the last time a Falcon 9 rocket basically had a major failure. I mean, there have been a few engine failures, etc., with problems of putting things in orbit, but you don't see boosters failing. Starship's a slightly different case, but Musk has made space reliable, and that's really key. What he's also done, though, is he's invoked a new sense of imagination and a kind of asking that constant what if, and if you say no, I say yes sort of thing. How do we do hard things? JPL's kind of motto is dare mighty things. SpaceX's motto is probably do mighty things, basically. And there's a difference there. So what SpaceX has also done is it's created a generation of engineers. So numerous engineers who started at SpaceX have gone off to found other companies like Varda Space Industries or Axiom Space or Astra Labs, etc., and so on. So it's in a way, it's not just been a company, it's been a university for entrepreneurship in space. And I think that's probably the greatest gift SpaceX has given us. As I said, Musk is extremely polarizing. His ambition is to go to Mars. No one's really sure why. He talks about, basically being, a multi-planetary civilization. There's other ways we could get around doing that, basically. But, SpaceX's predominant mission is to get to Mars, which means generally, they're focused on some technologies like Starlink, etc., and Starlink and Starshield help empower SpaceX because they are a customer for their own products. But most of their focus is how do they get to Mars? And that's literally all they're focusing on.
Interesting. All righty, let's go back into mindset, because I think up to this point it's been a deluge of fascinating information. And what I'd love to know is understand your mindset to this point of also how we've got here and your approach to things. So what have been your biggest learning curves along the journey for you as a person? What have been, through the different things you've done, what have been your biggest learning curves about yourself and I guess the world?
So probably my guiding rule, and it's the same rule I share with my team, is just because you can doesn't mean you should. So there are certain things you shouldn't do, even if you think it's a good idea. Never touch a high voltage capacitor, especially with your tongue. That's a really bad idea. Don't do that. So firstly, I think kind of, there were driving principles which are core to me. So one of those basically is knowledge. But knowledge shouldn't be gained at the expense of all others. Knowledge needs to be gained in ways which basically is responsible. And knowledge also should be shared. But you then need to be careful who you share it with. So there is so much you can do and arguably so little time to do it. You need to be quite selective about what you pick and how you do it. And we're quite good as humans, and it's probably one of my failings is I'm quite good at making an argument for why I shouldn't do something rather than making an argument for why I should do something.
Interesting.
And
have you been like that from the start, or have you developed that?
No, I think that's probably. I mean, I've certainly got better at it, recognizing that just because I think the opposite idea is a bad thing, therefore I should do this thing instead. It's something I've become probably more cognizant of as I've progressed through my career. But certainly in my early days, I did a whole variety of things that retrospectively I probably never would do now, and I can see with hindsight why I did them. But at the same time, just because you do something, just because you think you have the best product, because when you look at your competitors, their products just aren't as good. And, I've done that with companies that I've spun out, and some which have failed, some which have been successful, etc. Recognizing that just because you think it's a good idea doesn't mean that everyone else is going to think it's a good idea, and convincing yourself that you're right and they're wrong because you know more because it's your product isn't necessarily a good route to take. Other lessons I've learned around that basically are things like compassion. And I judge people less than I do, but I probably still judge them more than I should. And it's very easy to judge someone until you've walked in their shoes. So always within reason, unless they were an absolute idiot and you completely, they are about to touch the high voltage battery, etc., and you've told them several times don't do it, at which point you just have to leave them to it and hope they learn by example. Basically, it's hard, but giving them the benefit of the doubt, trying to see it from their perspective, actually benefits you both. So I think that's really important. And I think the other one is basically it's about not giving up. There are multiple routes to basically crack a coconut. And if your first approach was basically trying to bite on the edge of the coconut, you'd probably realize rapidly, and as would your dentist, this was this really stupid idea. But there's a whole variety of other ways you can basically crack a coconut. And sometimes the easiest one is basically hit the coconut on a hard thing repeatedly enough. I wouldn't say that's particularly effective, but it does help you basically see things from different perspectives. So, if I was going to, it's about sharing knowledge, it's about compassion, and it's about tenacity, basically. And I think those are three things for me, as well as the just because you think you can doesn't mean you should. Basically, those are kind of probably my kind of key guiding principles.
Yeah, I love that. Fear of failure. Has that ever been something which has stopped you, held you back, made you take a different path?
When I strapped a pair of rocket engines to my friend Andy, because strangely the BBC were paying us to see if we could make Andy fall towards the ground faster than the peregrine falcon he was racing, which is one of those strange things projects you occasionally do. And Andy was about to jump out of the plane with the two rocket engines attached to him, and I was wondering whether the rocket engines would set the plane on fire or Andy on fire. There was definitely a sense of failure associated with that this could go very wrong. I mean, I have to say, basically, embarrassingly, I was more concerned for my own reputation than I was for Andy or the plane. In the end, we didn't quite take that route, and we ended up using some electric ducted fans. I mean, Andy did go faster than the peregrine, and Andy did survive.
Wow,
so I still feel okay about that. But yeah, there's always a little bit of a concern about fear of failure. But I think once you work out that there's two aspects to failure. There's one, it's the personal aspect, and then the one, it's about the others' perception of you. If you can recognize that most people's others' perception of you will only basically be magnified if you make it into a big deal, then the reality is fear of failure is actually a fairly healthy thing to have. It's maybe not fear of failure, it's fear of failing to deliver, or fear of letting yourself fail. So, we were talking earlier about play. In order to learn, you have to fail. And if you never fail, you ultimately will never succeed. Or worse, when you do basically fail, and if you've never failed before, and you see this happen with a lot of, very smart kids, a lot of newer entrepreneurs who have never failed before, suddenly they have failure. I think the worst place to be would be to have never failed, because you never would know the flip side.
Yeah. And
you wouldn't know how to deal with that consequence when it happens.
Yeah, I could totally agree. How important is it for you to surround yourself with the right people? And I can imagine in this area you're in and everything you've done, people are what makes things happen, and actually being with like-minded people is the only way to innovate and grow. So how important is it for you to find the right people?
It's really important. I mean, at the moment we're going through, in the Catapult and other organisations, we're going through some ramifications about how we talk about hybrid working. Are people better working remotely? Are they better working together? And the general consensus is if you want to innovate, you have to participate.
Yeah.
You can't do it in isolation. Humans, you can do loads of things online. You can use products like Miro and things like that, and Teams calls, etc. But there's a real difference sitting in the same room, basically having a conversation. I mean, I would imagine it's the same doing a podcast in a way. Basically, there's a very different dynamic, basically, of doing it remotely, where you can't really read the other person,
100%.
To sitting in the same space. So, yeah, absolutely, having the right people around me, having the right level of innovation, having the right sort of effectively dynamic. Basically, it needs to be exciting. It needs to be dynamic. It needs to be challenging. It needs to be a little bit confrontational, but it also at the same time needs to be compassionate. Basically, you get those right dynamics together, and you can do anything. Put a whole bunch of people remotely and get them to try and solve a challenging problem. Chances are one of them basically has gone to sleep, one of them's turned the webcam off, one of them's basically petting their cat, and one of them's not even in the room. Basically, you don't solve problems. 100%. Humans don't solve problems remotely. Basically, we solve them together. And when we solve them together, I think everyone basically, all ships rise on the same tide. And when you achieve success in that respect, everyone rises.
I totally agree. Leadership, we've talked about obviously different types of leadership. What does it mean to you, and how have you evolved as a leader as you've got older?
So I talked earlier about leadership in terms of, for me, leadership is about accountability, and it's about accepting, it's taking responsibility for the outcome, regardless of whether the outcome is good or bad. But it's also about protecting your people. Nobody sacrifices their team to achieve their task. Caveat, sometimes you do have to sacrifice the team to an extent to achieve the task. And it's recognizing the difference between the two.
Yeah.
So for me, leadership is really core. I like to lead rather than be led. but I'm going to be led. I want to ensure the person leading is a good leader.
Mm-hmm.
And leadership is a combination of it's technicalities, it's emotions, it's subtleties, etc. It's being able to not necessarily do the job of everyone in your team better than they can do it. In fact, that would be the worst scenario. But it's the willingness to be able to understand the role of every single person, and the willingness to recognize there are people in the team who will simply be better at a certain thing than you will be. It's, leadership shouldn't be about competition internally. It might be competitive externally, but it's about basically building a team and growing the team at the same time. The team should always be greater than the sum of its parts at the end of the task than before you started the task.
Is there a problem with ego in the kind of innovation space? I only ask this question because having studied architecture and been in that environment, there most definitely is an ego problem in the design industry for that thing. And I think because people put so much of their own personality and their time into something, like, is that a struggle for you also as a leader to also understand the personalities of the people you have there and also control them and not allow their egos to get ahead of themselves and kind of imprint on too many ideas and technologies?
Yeah, I mean, it's a fair point. Egos are difficult, but what you want people to have egos, but you want to kind of have collaborative egos as well.
Okay.
It's trying to achieve the balance between having an ego but not being too, basically, I suppose, reticent to engage.
Yeah.
But at the same time, not allowing your ego to over-dominate. So we all have egos, and that's a natural part of human psychology. Understanding basically how big your ego is, or what it takes to satisfy it or keep it happy, that's more challenging.
Yeah.
And if you're trying to build a team or you're running a team, etc., and there are too many egos involved, basically, and everyone wants to do their own thing, you're not going to achieve your success. So it's trying to work out how do you find that balance in such a way that you can achieve that. Sometimes in the military we have things called command tasks, which are designed to basically nurture leadership, and we have command tasks which are led. So you've got 5 pieces of string and a barrel, and 2 planks of wood, and you need to now cross the Valley of Crocodiles, basically, in a certain amount of time. And you have a leader who comes up with basically a solution, and it's their role to basically implement that solution. Those ones are always quite fun because, to an extent, everyone has to participate, but it's the leader's problem to get it right. The difficult ones are leaderless tasks where there isn't a leader and everyone has to participate. And what you always end up doing is you end up with basically someone's ego surfacing who's like, no, it's a completely stupid idea. You can't do it like this. We're going to do it like this. Now follow me. And the intent of those exercises is to avoid that happening.
Yeah.
And that's trying to get basically collaboration between multiple leaders, I think, is very challenging. I mean, you see it in politics.
Yes.
I mean, you put a series of basically politicians in a room and you tell them they all need to come up with a plan. Basically, it will break into factions very rapidly as one faction will insist that, or one individual, they have the best plan and everyone else is wrong. So it's really a big challenge. And as you've said, in terms of architecture, I think it's as prevalent in architecture as it probably is in any type of engineering or science or technology, or equally the humanities. I think that is just a consequence of basically putting people with big ideas in the same space.
Interesting. Imposter syndrome. Have you ever suffered with that? And you're in an industry where there's a lot of very, very intelligent people, fast thinking, quick minds. Do you ever get there?
Sometimes, yes. I mean, fortunately, it's usually fairly brief, but there are times when I think, and occasionally when I'm doing a panel or I'm doing a keynote or something, and I start off and then thinking, hell, why on earth are they listening to me? They're completely mad. Why do they think I know better? Yeah. I was explaining at the Jet Propulsion Laboratory last month about technology we're planning to use in terms of the ISAM environment to a group of very senior NASA engineers and an astronaut. And I had this kind of moment of this abject horror to myself of, how did I get here? Why are they listening to me? They need to get. I need to leave. They clearly, whatever they believe basically about me is wrong. I'm just talking pure hyperbole. I need to get out of here. But then you have to ground yourself, and you have to think is, if they believe that, you wouldn't be here. And if they are generally humoring you, well, frankly, you've got nothing to lose anyway. Basically, they probably will let you leave alive. Basically, but I think it's good to question yourself periodically. I think it keeps us grounded, because otherwise your ego can go unchecked. So I think actually a little bit of imposter syndrome is really quite healthy.
Yeah, no, I don't disagree. I don't disagree at all. The biggest self-limiting belief you've had, which you've had to overcome.
Ooh, that's a challenging one. Biggest self-limiting, probably that it's already been done. So the world has got so big and information is so diverse and available. It's quite hard to think you can do anything unique, and it's quite hard to think that you actually have a unique thought because with the growth of the internet, with so much information at our fingertips, you can access. It's very hard to say I can do something different. And I think for a lot of my early ideas and innovations, etc., and then later ones, there's always been a sense of, well, why is it any different? If you can think of this, 1,000 other people can think of this. The concept of patenting is got really quite hard. The definition of a patent is an idea which is patentable is an idea which an expert skilled in the art would not think of naturally, and that because it has to be so distinctive. And with the emergence of pseudo AIs, etc., it's really hard to do something original. But actually, we can do original things, and we all do original things. I mean, this podcast is an original thing. No one has done it. It's an original thing by virtue of the conversations we have. So I think the biggest self-limiting factor I struggle with, and I still struggle with on a daily basis, is recognizing that I can think of original things, and maybe they're not all going to be entirely globally transformational. Maybe one of them will be, maybe none of them will be. But you can still be original in a world where it is so hard to be original, or the perception is that it's hard to be original.
Yeah. I've related to that a lot actually with my own art and stuff like that I do, especially if you go to museums and galleries and stuff like that. You see a load of artists and you go, oh God, I'm quite similar to them, or I'm quite similar to that. It's very easy to find similarities. And also it's because everybody's got sometimes very similar references as well in some sense, haven't they? Someone's always thought of something and done something. And
that's one of the reasons I would, go back to things, why do we go into space, etc. And it's not just space, it's the other frontiers, the bottom of the seabed, the vast deserts and oceans and things like that. But it's to find inspiration, because there will be a dozen different ways of doing something that you will get from an experience of doing something that others have not done before. And that's possibly why you want to do that. Seeing, there were certain parts of the dark side of the moon no human has ever laid eyes on.
Yeah.
So some people, there's going to be, so much, kind of scientific knowledge which we gain from that. From others, it will be this new form of dark, which they think, hey, I can do a great pastel, basically a creation around this or something like that. Basically, we're seeing a lot of artists wanting to go into space, and I think part of that is driven by they're seeking innovation and they're seeking originality. They're looking for things that help spurn them on to do something different.
Yeah,
I think the great thing is the universe is so big, so ridiculously big. I mean, the solar system is big. The galaxy is vast, etc. There is so much unknownness out there that all of us can be original, because there is an infinite amount of originality out there. So I think whoever you are, never be concerned you can't be original, and we are all original by our very DNA. So every instance of every human ever is a unique instance of a human. So you are original in yourself. Therefore, things you do can be fundamentally original as well.
Okay, final 4 questions. Young people, how do we change their mindset, get them thinking more innovatively, get them more creative, away from worrying about their social media platforms? Like, what can we do as a generation to help them and trying to spur them on to be the innovators, the free thinkers we look back at the past and are inspired by?
So certainly that kind of aspect of encouraging play, I think, is really important. I was reading an article recently about US boot camps, which are just doing digital detoxes and things like that. I actually think those sort of things are actually not a bad idea. I think a key one is basically collaboration. So basically encouraging children to basically participate in things like clubs and scouts and guides, etc. Places where they can be removed from digital devices to an extent where they can basically associate with their peers, etc. And allow them to grow up at a steady rate, not accelerate their growth, not try and get your child to basically learn a dozen languages and 4 musical instruments and be declared a mathematical genius by the time they're 9.
Yeah.
Hell, that sounds truly awful.
Yeah.
You know, a 9-year-old should be basically doing whatever a 9-year-old does.
Yeah.
You know, a 9-year-old me was trying to make gunpowder. I wouldn't recommend that to all 9-year-olds. But running through the woods, or the urban equivalent of the woods, etc. But I think connection with nature is important, and that might sound trite, and it might sound, a little bit samey in a way. But I think embracing the natural world and being able to leave your digital devices, etc., around basically goes a long way. I think also the other aspect is the ability to look after something. I wouldn't recommend that every child should have a dog or a cat necessarily, but I think there is a significant lesson in learning about that, having it something else which is dependent on you and being able to treat it well, because if you can treat a pet well, you'll treat others well.
Yeah.
So it's that aspect of play, originality, compassion, it's something I come back to a lot, and also that ability to connect with the real world, basically. And I'm not saying the digital world isn't real, but the digital world is an interface to the real world.
Yeah.
And we never should forget that.
Yeah.
The moment that we try and surround ourselves in purely virtual worlds, however real they smell or they touch or they feel, etc., it's still not the real world.
Yeah. Yeah. How important do you think it is for young people to follow passions and interests in their career path? I've got a lot of friends at the moment, and I've got one actually who's just quit his job. He's bought himself a bike and he's cycled, he's on his journey now, he's cycling from London to Morocco to go surf on the west coast of Morocco, just because he's done a career path which his family have been in, he followed the same path as that, and he got to a point and he went, this doesn't stimulate me, and had a few things which influenced that. And now he's going out seeking adventure, seeking something new, seeking a bit more presence. How important do you think it is for people to then independently find passions and careers and interests and go down those routes?
Pretty important. I mean, you can get yourself into a sort of lane that you never leave, and you simply are going to pursue that endlessly, relentlessly, because someone else has said you should do it, your family says you should do it, your education says you should do it, your peers, your friends, your partner says you should do it. And if that makes you fundamentally ill at the end of it, that's probably not a journey worth taking. I think there are times when people think, you know what, I've had enough. I'm going to throw in the towel. I'm going to buy a bike. I'm going to cycle to Morocco. I'm going to spend the summer surfing.
Yeah.
And that's probably not technically always the answer.
Yeah.
There needs to be a sense of proportionality. But I think it's, healthy reflection is really important. Being able to pause and collect your thoughts and work out, is this where I really want to be? Now, not everyone necessarily has the opportunity or privilege to do that. And, that varies in terms of which world you come from and how you live and your economic and your relationship and constraints and so on. But I think fundamentally, if you are unhappy doing something and it makes you unhappy, and, there are various, combat indicators that suggest that, not sleeping well, not eating well, struggling with relationships, etc., unhappiness with yourself and so on. And they usually manifest one way or another, both physically and emotionally. Then it's probably a good time to reflect that.
Yeah.
And, you can change your career, you can change your direction at any one point. A professor I knew at the University of Swansea became a professor fairly late in life. Up to his mid-40s, he was a hermit living on a mountainside in Wales. And he had a fascination with making pottery and was fascinated about how he could use various minerals to make his pottery different colours of blue. And he went to the university one day and said, I'm really interested in this, and I want to understand why. They kind of look at this dirty hermit, etc., who seems to have an amazing grasp of chemistry.
Yeah.
And then 10 years later, he's the head of the faculty, basically. And you're just like, how do you connect? So, that's a complete shift in terms of, can you imagine him meeting the king? King's like, what were you doing 10 years ago? Well, Your Majesty, I was living in a hole on the outside of Cardiff, looking down over the city, sort of thing, basically. But rags to riches, perhaps, rags to knowledge. I don't know.
Yeah.
But there's never a point in your life where you can't say, you know what, I'm going to do something different.
Yeah.
I think part of the, we don't talk about careers per se or having a career you follow for life. We talk about careers, plural. Do different things. Will I be doing science and engineering and space in 10 years' time? I don't know. Maybe I'll be running, a donut shop in Chelsea?
Mm-hmm.
Will I be
or in orbit?
Or will I have sold all my possessions, packed my cat into my backpack, and be heading on a surfboard basically down the coast of Africa? I don't know.
Yeah.
But those possibilities exist.
Yeah. I think there's an element of people, especially I did it for myself. You put pressure on yourself that actually you take a decision at university and you have to stick to it.
Yeah.
And that's a real issue.
And I think that's changed a lot. And I think people increasingly going to university are increasingly questioning why they're going to university. Can they get similar experiences? Can they get similar backgrounds? One of the things I find quite reassuring is the number of job adverts I now see scattered around the internet, LinkedIn and things, which now don't just say you must have a degree in this. Yeah. It says you must have a degree in this or practical equivalent experience. Amazon in particular seem to be doing this a lot. And I think that's changing. That's an expectation change of the corporate world, recognizing you don't necessarily need a qualification to be good at something.
Mm-hmm. Mm-hmm. I agree. Okay, final two questions. What are your drivers to success?
So, I would be probably insincere if I didn't say some of that was material and financial wealth. So stability, basically. Yes. If you're stable, you can do more things with more resource, you can do other things, etc. So that's a balance between the material world and everything else. So that that's partially. A big part for me is basically fun. I like to enjoy myself. I like to learn things, and for me, learning things equates success. Success equals fun. Fun is a motivational factor. It's kind of like an OODA loop, around it goes sort of thing. So for me, from a motivational perspective, I want to know more, but when I left university, I had this kind of guiding construct for me, which was kind of three things, which was make money, that's the financial aspect, do cool things, that's the fun aspect, basically, and make the world a better place. And my intention was to try and achieve all three of those. Now, if I achieved only one of them, I'd probably be okay. Having fun is definitely good. Making money, well, I said about databases, it was truly awful. That's not a good one. And making the world a better place than you found it, I think that's really important. So for me, if I can achieve a couple of those, then that's a really important, I'm doing some, it's more than yourself alone. Leave the world in a better place.
Yeah.
Have fun while you're doing it. And if you can earn enough or acquire enough, etc., legally, hopefully, then basically, then you can, tend to those other, effectively needs you might have.
Yeah. Okay. Final question. Do you have kids?
Not currently.
Not currently. Okay, so what would your one lesson about life and happiness be for your future children?
Don't judge yourself for mistakes you make, for a start. Try not to make those mistakes repetitively. If you thinking you can fly by jumping out the window is not going to be a good lesson, basically. So be kind to yourself, be kind to others, and never stop asking why, basically, because why can't I fly faster than the speed of light? Well, the standard model says, what happens if I change the standard? Why is the standard model like that? Well, because of this. Well, why is wave particle duality like that? Well, it is. Well, what about if I do this? Oh, I've broken the standard model. I can go faster than the speed of light. And off you go, basically. So for me, basically, asking that question why, within reason. Clearly, why drives many parents basically mad. As I wouldn't recommend to small children just ask why endlessly on repeat, but why with intent and purpose, and at the same time, basically being able to forgive yourself when you make a mistake and forgive others when they do so will probably do you no harm and set you up on a path to. Well, maybe not basically making improvisers explosives at age 9, but certainly a route where basically you only jump out the window once, and along the way you have some fun.
Fantastic, Mike. Thank you so much.
My pleasure.
Outlaw number 38, and it's been fascinating. We've gone through a range of topics there, and we could probably go on for hours more. But this has been fantastic. I really appreciate your time. Thank you for coming on the Valley of Outlaws.
Thank you very much.
Cheers. Thank you for listening to the Valley of Outlaws podcast. If you like what you heard, please subscribe and follow us on Spotify and YouTube.